what we're going to do today is we're going to start off by uh, going back and looking at how do you solve just basic one variable equations. Like, uh, let's just look at an example. Of course, we have a basic equation, maybe like 2x plus 1 equals 5, something like that. And this is just a two-step equation. And something we encounter pretty early, even before we take algebra. A lot of times you'll see something like this. But remember the steps. You can add or subtract anything you want from both sides, as long as you do it to, as long as you do it to both sides. You kind of think of it as a scale. You keep it balanced. Then, so I isolated the x term, and then I'm going to finally divide. And I get x equals 2. And of course, you can check that result by plugging it back in there. 2 times 2, 2 times 2 is 4, plus 1 is 5. Sure enough, so that's a solution. So there's just a basic two-step equation. Now, of course, what happens is you start adding things onto it. For example, you might have something like this: 3x plus 2 times x plus 1 equals 3. Now it's more than just a two-step equation. You've got some work before, a little bit of extra work. First, you notice we've got a parentheses here we need to clear. So we've got x plus 2x plus 2 equals 3. Just using distributivity. Then we can combine like terms. This will be 5x. 2 equals 3. And then subtract your 2. 5x equals 1. Okay. And then divide. And you get x equals 1/5. Okay. So that's just a little bit of review. Everybody remember that? Now let me ask you this. While we're talking about this, why does this law of distributivity work? In other words, why can we say this? Why can we take 5x plus 3 and call it 5x plus 15? Why can we do that? Any ideas? Well, remember what's happening when we talk about multiplication. This right here, doesn't this right here just mean this? 5x plus 3, doesn't that mean x plus 3 plus, there's 1, x plus 3, 2, x plus 3, there's 3, x plus 3, that's 4. See, you've got 1, 2, 3, 4, and then one more, 5. So 5x plus 3's, that's what this is, right? And you can see 1, 2, 3, 4, 5 x's plus 5 3's. Okay. So that's why the law of distributivity. We just call it the law of distributivity, but it's just multiplying. Okay. Now, what we want to do, we want to kind of build on this and go into the next step, and that is, how do we handle decimals and fractions? For example, now, really, you don't have to do anything special with equations with decimals or in equations with fractions, but there's a little bit of preliminary work that you can do to make your work easier. For example, let's suppose you've got 0.5x plus 2 equals 7, something like that. I'll put a 0 here to kind of accentuate that decimal in front. Now you could go, solve this as usual. Go ahead and subtract the 2 and then divide by 0.5. One of the things that might make things easier for you and cut down on the likelihood that you'll make an error is beforehand, just go ahead and clear your go ahead and clear the decimal. And what I mean by clearing the decimal is this. Remember that if you have, let's think about 0.1. And imagine if you multiply that by 10. Well, that just moves the decimal one place to the right because you're multiplying by 10. Now, let's suppose you've got 0.1, you multiply it by 100. Well, that multiplies it two places to the right, right? So by multiplying by some power of 10, it moves the decimal to the right several places. Now, what if I take this equation? Well, which one? Oh, it would be. You know what that means? Oh, you get a Mackey sticker. That's right. Okay. You're the first one. Here you go. This is a very happy time. You're welcome. Yeah, it would be a, because you're moving it 2 places, not just 3 places. So, there you go. Now you see the idea that when you multiply by, a power of 10, it moves the decimal to the right. Now imagine if I multiply everything on the left of this equation by 10 and everything to the right by 10. Well, what it does is it just moves the decimal 1 place to the right. And that would clear this fraction. That would clear this decimal. So look, what I could do is I would have 5x, move the decimal 1 place, plus 20 equals 70. Now I don't have those decimals that could cause me problems in my arithmetic. So I just subtract the 20, and now I have 5x equals 50. Okay? Yes, sir?
Anytime there's a decimal.
Well, some power of 10. We'll look at one where you don't necessarily do 10, you do maybe 100. I'll show you. So here we go. We divide by 5, and now we get x equals 10. Okay? And sure enough, look, 1/2 of 10, that's 5, plus 2 is 7. And that works. So now you don't have to, you don't have to be cognizant of the idea you're multiplying by some power of 10. All you have to do is move the decimals over far enough to get rid of them. So look at this. Let's suppose we've got 2.25x plus, let's say, 0.3 equals 4. Now, notice if I just move the decimal 1 place over, I get, I'll have a 3 here, but I'll still have a 22.5 here. What I need to do is say, okay, how far do I need to move the decimal to get rid of the, the one with the most decimal places after it? In other words, look at this. We've got 2. This is 1. I'm going to move everything 2. That's what I have to do. 225x plus 30 equals, let's see, if I move it 2 places, it's going to be 400, isn't it? Okay. See? You just have to be aware, okay, I need to move the decimal enough to get rid of all of them. Moving it 1 place wouldn't, I'd still have a decimal there. Okay. Now, I can subtract the 30, and I get 5x equals 307. Is that right? Yeah. Okay. Now divide. Okay. And there you have it. X is equal to 370 over 225. And then you could reduce the fraction. Okay. Any question? And of course, the obvious would be, well, how many times will 5 go into 370? How many times will it? Well, into 100 it will go 20 times, right? So here's 20, 40, 60. That's 300, right? And then you've got 3 more, right? So you've got 20, 40, 60, huh? Okay, so you've got, there's 300, and each one of these is 20. So there's 60, and then you've got, what are we doing? Oh, yeah, 5. So how many times will 5 go into 70? Okay, so what's the total up here? How many times will 5 go into 370? 24? Okay. How many times will 5 go into 225? Okay. There we go. I think that's reduced. Okay. Any questions? Okay, so that's how we can deal with these decimals. And probably all of you have seen that. That will really be helpful to you. Before you start working the equation, just do a little bit of preliminary work, clear the decimals. Now also there's the fractions. And let's suppose I've got like 1/4 x equals 7, something like that. What I like to do, now this is a simple one where you don't have to think about I'm clearing fractions or anything, but notice if I just multiply through by 4, I've cleared the fraction. So I've got 1/4 x equals 7 times 4. Now notice these 4's cancel. Now you just get x equals 28. Okay. So, that's all I had to do to solve that one. But let's suppose we have something like this. Let's suppose we have something like 2/3 x plus 5/6, now let's say x plus 1 equals 4. Okay. Now, what I would do if I were solving this, I wouldn't try to clear the parentheses and add like terms and all that with these fractions involved. What I would do is I would try to clear these fractions out. And that involves multiplying through by the least common denominator, which I have a 6 here and a 3 here. So the least common denominator is going to be a 6. So what I would do is I would multiply through by a 6. Okay. So here we go. Here's 6 times 2/3 x plus 6 times 5/6 x plus 1 equals 6 times 4. Like that. Okay. Now notice I did not multiply. I multiplied 6 by this, and notice that will cancel here. I didn't say 6 times this and this, because these are just looked upon as one factor or one term. Okay. You're not going to multiply by both of them. It's sort of like this. Let's suppose I wanted to say 2 times 4. Or let me change that a little bit. Let's say I want to do 2 times 10. Well, that's obviously 20. Well, let's suppose 10 was written as 2 times 2. I mean 2 times 5. Okay, 2 times 5. Well, this is the same thing, but notice the answer is 20. Now, obviously, I'm just going to say 2 times 5, which is 20. I'm not going to say 2 times 2 is 4 times 2 times 5. That would be 40. See? This is what we would not want to do. That's why when you're multiplying through here, I'm not going to multiply 6 times the first of this and then 6 times the second part. Okay? So now look, 6 divided by 3 is 2. These 6's cancel here. So let's see what we've got. This is going to be 2 times 2, that's 4x. Plus 5 times x plus 1 equals 24. Now we're done with the fractions. Okay. And now we can clear the parentheses. Gather like terms. Okay. And then just go and solve it. With each step, the equation gets simpler. So we have 9x is equal to, what would that be? 19? That's right. Okay. And then x equals 19/9. Now, by the way, I would just keep it 19/9. For this class, you don't need to try to turn it into a decimal or anything. 19/9 is fine. Or you notice this is an improper fraction. That's fine too. 19/9 is fine. Now in Math Excel, you put in whatever form they tell you, but 19/9 is just fine for this class. I don't mind improper fractions. Okay. Any questions? Okay. So this is all kind of a review for you. Seen this before? Okay.